In this video, we are going to discuss about the quadrature amplitude modulation. On completion of this topic, the students will be able to understand the principles and generation of the quadrature amplitude modulation. So, quadrature modulation, amplitude modulation is nothing but it is a method of combining the two amplitude modulation signals into a single channel. Okay, one signal is called as I signal and other signal is called as Q signal. So mathematically one of the signals can be represented with the sine wave and another with the cosine wave. This is mostly used in the modulation scheme for the digital telecommunication system. Also this is limited only by the noise level and linearity of the communication signals. This quadrature amplitude modulation is used to achieve high levels of spectrum usage efficiency. That is, this is accomplished by utilizing both the amplitude and the phase components to provide the form of modulation. So it contains two carriers. It is used in the microwave and the telecommunication systems. The 64 QAM and 256 QAM are used in the digital cable television and cable modem, and also it is used in the optical fiber system to increase the bit rates, and it is used in the many communication systems like the Wi-Fi, digital video broadcast and WiMAX. And the QAM signals, one signal we call it as I signal and one signal we call it as the Q signal. So mathematically one of the signals can be represented the sine wave and other by the cosine wave. The two modulated carriers combine at the source of the transmission, and at the destination these carriers will separate and the data is extracted from each. So then this data is incorporated into original modulation or what original modulating information. And quadrature amplitude modulation advantages. Quadrature amplitude modulation is a signal in which these two carriers are shifted in phases with 90 degree. Since we have one sine wave and cosine wave, they are modulated and combined. As a result of their 90 degree phase difference, this results in the quadrature and they give rise to the other name. So one signal can be in I phase and another in the cosine signal. So the resultant will combine and form the amplitude and the phase variations. In view of this, both the amplitude and the phase variations are present. It may be considered in the form of mixture of amplitude and phase modulation. And the disadvantages, it appears to increase the efficiency of transmission for radio communication system, and this can utilize both amplitude and phase variation. That is one of the drawback of this. That is, first one which is more susceptible noise is states that it is closer, states are very close together, so that the lower level of the noise is needed to move the signal to the different decision point. So these are the disadvantages. And another is these receivers will have if it is having the phase or frequency modulation is or not, or both are same means, or it are in phase means, they use the limiting amplifiers so that they can remove the amplitude noise and they can improve the noise lanes. This is not in the case of QAM. The second limitation is also associated with the amplitude component of the signal. So when phase of frequency is modulated means to the radio transmitter, there is no need of using the linear amplifiers, whereas when we are coming to the QAM, this combines with the amplitude component and the linearity must be maintained. So this linear amplifiers are less efficient and it consumes more power, and this makes more attractive for mobile applications. So as an example of this quadrature amplitude modulation, 12 different phases are combined with two different amplitudes. Since only 4 phase angles have two different amplitudes, there are totally 16 combination, that is 2 power 4, which is 16. So you can see the quadrature amplitudes, 4 phases. While combining the ASK and PSK, it corresponds to multiple bits and it has more phases than amplitudes. The minimum bandwidth is same as ASK or PSK. Thank you.